what does refraction at spherical surface tell us? What is the formula for it? Mu2 by u. mu2 by mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. Right. Right. So remember this derivation. Now I'm giving you another task. So what was the scenario under which we derived this? Left hand side was a rarer medium and right hand side was a denser medium. The rarer medium had refractive index of mu1 and the denser medium had refractive index of mu2. And the object that you considered was a point object. Now my question is, if I have the same surface like this, and this is a denser medium, this is a rarer medium. If this is mu1 and this is mu2, okay, then if I keep an object here, then how do you find the location of the image for this? Okay, first draw the ray diagram for this. After that, apply the same logic that we did yesterday and derive that expression. Derive. Notes in there. Those who are on it, how many of you could draw it? At least try all. Try all. You know what happens when it goes from denser to rarer, right? Try it at least. Two of them have drawn it correctly. Yours is right. Yours is right. Simple logic. I don't know why everybody is peeping into others' notes. Right? It's a simple logic. How did I ask you to draw a radii? First is you take a point object. From there, you have an incident ray. At the point of incidence, what are you supposed to do? Draw a normal. So when you draw a normal, that will pass through the center of curvature. This will be the actual path. Then what are you supposed to do? When the ray moves from denser to rarer, what happens to it? When you know it theoretically, apply it. No, it moves away from the normal. So image is formed here. That's it. That is what it is. You didn't think about this. You're telling it, but why didn't you draw? Clear? If this is alpha, beta, and theta, okay? This is the angle of incidence. Then this whole thing will be the angle of refraction. What are the two triangles you will consider? So if I take this as M, then you will consider the triangle MOC. And this will be I, this will be alpha, this will be theta. So what is the relation between them? I is equal to alpha plus theta, which implies, okay, that's it. Let this be equation number 1. Similarly, if you consider the triangle MIC, this angle will be R, this angle will be beta, this angle will be theta, which implies R is equal to beta plus theta. So let this be equation number 2. Right. When you apply mu1 sin I is equal to mu2 sin R, you will have mu1 into I is equal to mu2 into R, or you will also have mu1 into tan I will be equal to, or to put it in simple terms, yeah, you can write it in this way also. Steps are the same. Mu1 into tan I will be equal to mu2 into tan R. Okay. Having this in mind, you will have mu1 into, what is tan I? Tan I is tan alpha plus tan theta. Similarly, mu2 into R will be tan beta plus tan theta. So mu1 into, what is the value of tan alpha? So what is the value of tan alpha from the triangle? MP divided by, how much is this distance? This is U, this distance is B, and this distance is C, radius of curvature. Is it clear? So mu1 into tan theta is how much? Sorry, tan alpha is how much? MP by minus U plus tan theta evlo? MP by correct part solla. MP by, sorry, R sonia. That's right. Mu2 into what is tan beta? MP by R kadiyadu. Tan beta minus V plus MP divided by R. Okay. So remember this step, this is very important one. I'll tell you the difference. So MP gets cancelled. I'll have minus mu1 by U plus mu1 by R is equal to minus mu2 by V by plus mu2 by R. So if I rearrange the equation, I'll have mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Did you get the same expression? Did you get this value? So mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. So why I told this particular step is important is because if you proceed with the same derivation without applying sign convention, you will not get this option. Okay. Then what would have happened is, how many kinds of scenarios can you define in this way? When you have a boundary, a spherical boundary, left hand side can be denser and the right hand side can be rarer, and you can keep the objects at different locations. Means multiple options are going to come into picture. For every option that you get, if you don't apply sign convention, you would have got a new formula. Now, this formula will be the generic formula for wherever refraction is occurring at the spherical surface. Is the point clear? Okay. So remember this expression. This is very, very important. The next concept that we are going to discuss is about lens. Okay. So what do you basically mean by lens? Lens is an optical instrument. Can I call it as an optical instrument where you have how many refracting surfaces? Where you have two refracting surfaces, out of which at least one refracting surface should be curved in nature. Can I say that? Why am I using the word at least one? If both the sides are planar in nature, so only two shapes are possible. One is planar shape or spherical shape, right? Curved. So if both the sides are curved, it is not going to be a lens. It will become a prism, or it will become a rectangular glass slab, whatever it is. So basically, rectangular glass slab is also a prism. Yes. So what were we discussing? A lens is an optical instrument. So write down the definition. Lens is an optical instrument where at least one of the refracting surfaces is spherical in nature. At least one of the refracting surfaces is spherical in nature. Is that point clear? So based on the way the spherical structure is present, for example, I have a spherical shape like this, then what name do I give to it? So that depends on which side you are actually trying to see from. If you see from the left hand side, it is a convex surface. Whereas if you see from the right hand side, it is a concave surface. Is that clear? So if I take this surface and close it like this, then whenever you look at a lens, you need to always look from the outer side of it, because you're not going to put your eyes inside and see. So when you're seeing from outside, what happened? This is also convex and this is also convex. So since there are two convex parts available, you call it as biconvex. Bi is two, convex is the bent surface. So you call it as a biconvex lens, or in simple terms, you generally call it as only convex lens. Is that clear? Similarly, if I have a shape like this, when I see from outside, what do I have? I have a concave shape here and a concave shape here. So it is also called as biconcave or simply concave. So you will not generally use the word biconcave everywhere. Okay. Suppose I have a plane side and a side which is bent like this. What do I call this as? This can be called as plano concave. This side is plano, correct it? It's called plano convex. Clear? Similarly, if I have a surface like this, You call it as a Plano Concave. Right. So is there a possibility where you can have a shape like this? So this side is convex, this side is concave. Then how do you name it as? Convexo concave. So generally, if you want to combine the name of two shapes, you use a O as a connector. You can use concave or convex also. Just see it in the other direction. Just a name. Right. So based on this, if you try to proceed, then we mostly discuss about a biconvex lens and a biconcave lens. Okay. So generally, when you observe for a mirror has only one focus, whereas a lens has two focus. You call them as foci or foci. Right. Similarly, it has two centers of curvature, one on the left hand side and one on the right hand side. Okay. So when you take it in this way, the other names are similar only, except the fact that for a mirror you have a pole, and for a lens you have something called as optical center. These are all the different parts of a mirror, sorry, lens, right? So rules are almost the same. So when you talk about the rules of F1, F2, we'll have C1, C2, something like this, right? This is with respect to a concave mirror. If you see, the rules that you need to follow to draw ray diagram, rules to draw ray diagram for lens. First is, if a ray is considered parallel to the principal axis, what will happen? Ray considered parallel to the principal axis passes through focus. Okay. If you take a ray parallel to the principal axis, after refraction, will pass through the focus. This is optical center. With the concave mirror, concave lens, you take a ray parallel to the principal axis, it will appear as if it is originating from the focus. Is that right? So this is what happens. Second, if an object is placed at focus, what will happen? It is just the reverse scenario. Ray passing through the focus becomes parallel to the principal axis after refraction. So what will happen in this scenario? The ray is passing through the focus. So at the point of instance, what can you do? You can draw the normal through the center of curvature. Once you draw the normal, what should happen to it? It should start moving away from the normal. So it should actually come back in this path. First, it is going to get diverged. Okay. The third point is when the ray passes through the optical center. Third point is when the ray passes through the optical center, what will happen to it? It will pass without any deviation. So third point is write it down. When the ray passes through the optical center, it travels without any deviation. The ray through the optical center travels undeviated. Clear? So when a ray passes through the optical center, it travels undeviated.
So can you show the first?
Somebody asked for the first. You're done?
Yes, sir.
Now listen. Based on this, we are going to derive a formula called lens formula, a mathematical equation called as lens formula, for which I am considering one of the scenarios like this. So when you place the object beyond the center of curvature, let me call this as AB. Okay, when you place it beyond the center of curvature, the ray traveling parallel to the principal axis after refraction will pass through the focus on other side. And the ray through the optical center will travel undeviated. Okay, let's say here the center of curvature is there. The image would have formed between the focus and the center of curvature. If I call this as A dash B dash, then what is the distance AO called as? The distance AO is called as U, and the distance OA dash is called as V, and the distance OF is called as F itself. Okay. So as a part of construction, if I drop a perpendicular from here and I call this point as M. Okay. So first draw this diagram. Listen to this. So when you're trying to find the lens formula or mirror formula, what is the logic we use? We need to find two sets of similar triangles. So where is the first set? If you consider the triangle BAO, then what would be the corresponding similar triangle for it? B dash A dash O. Why is it so? Because if this angle is taken as alpha, the opposite angle is also alpha, and the other angle in both the triangles is 90 degrees. So since they are 90, what can you say? Triangle BAO is similar to triangle B dash A dash O, which implies B dash A dash divided by BA is equal to B dash O divided by BO. Is it clear? So let this be equation number 1. In a similar way, what are the other set of right angle triangles you're able to find? So if I take this angle to be theta, this will be theta. If this is 90, this is also 90 according to AA criteria. What can you say? MOF is similar to triangle B dash A dash. Which implies B dash A dash divided by MO. By MO will be equal to A dash F divided by OF. Let this be equation number 2. But if you look at the diagram, what is that you're able to observe? BA is equal to MO. Are you able to observe that? Is BA equal to MO? Yes or no? Yes or no? Right. So which implies from 1 and 2, so from 1 and 2, if you observe, you will have B dash O divided by BO is equal to A dash F divided by OF, which implies what is B dash O? One minute wait, actually B dash O is of no use actually. So I can write this as A dash O divided by AO. This one extra point. Upper, this will become A dash O divided by AO. So what is A dash O? What is A dash O? Ada evudo? B divided by what is AO? Minus U is equal to what is A dash F? B minus F. What is OF? OF is F only. Is it right? So which implies VF is equal to minus UV plus UF. So dividing with UVF on both sides, what will you get? 1 by U is equal to minus 1 by F plus 1 by V, which implies 1 by V minus 1 by U is equal to 1 by F. This is what we call it as lens formula. This is clear. Okay. The next part is linear magnification of lens. So linear magnification of lens. How is it defined as? It is defined as the ratio of size of the image to the size of the object. So linear magnification of lens is defined as a ratio of size of the image to the size of the object. Clear? So it is represented by the symbol small m. So small m will be equal to a dash b dash divided by ad. Or I can write it as b dash a dash divided by ab also. Right? But observe from the diagram and from equation number 1. So if you observe equation number 1, which you have written down, you can say a dash b dash divided by AO is equal to how much? AO, sorry, A dash O divided by AO. Third equation, first equation. A dash B dash and B dash A dash are same term. Oh, I wrote AO. A dash B dash by AB is equal to A dash O by AO. Is this point clear? Right. But observe. What is A dash B dash? It is the height of the image and AB is the height of the object. So A dash B dash is height of the image. Is it not an inverted image? So can I write it as minus HA divided by what is AB? It is H naught is equal to what is A dash O? A dash O is B divided by AO is minus U, which implies HI divided by H naught will be equal to V by U. And this HI divided by H naught is what is called as linear magnification. So the linear magnification for a lens is given as B divided by, whereas the linear magnification of a mirror is given as minus V by U. Okay. And what is the important point to be noted here? That you need to use a sign convention while you're solving problems as well. Purida. Okay. So the next point that we are supposed to define for a lens is power of lens. So this is what you know. What is power of a lens? What is it? The mathematically, yes, is one way. So power speaks about something related to focal length. Is that right? Now, if you see, if I have a convex lens, listen to this carefully. If this is O, from the optical center, I am considering a ray parallel to the principal axis. Okay, what will happen to this ray? It will start bending and the image is formed at the focus. So this distance I can call it as small f. Can I do this? Now if you see, the incident ray has taken a deviation in this direction, which I'll call it as delta. Is it right? Now, if the parallel ray is incident from the optical center exactly at a distance of 1 unit. Okay, if it is exactly incident at a distance of 1 unit. Now, if you see, if this angle is delta, can I call this as delta? Alternate interior angles. So if this is delta, this is also delta, alternate interior angles. Then tan delta is equal to how much? Can I write it as 1 divided by f from this triangle? Can I write tan delta is equal to 1 by f? Then this tan delta is what is called as the power of lens.
Sir?
So basically, yeah, tell me.
Sir, can you explain 1 unit? What is it, sir?
1 unit means I'm saying I'm taking a parallel, I'm taking a ray which is parallel to the principal axis exactly at a distance of 1 unit from optical center.
Okay, sir.
Okay. So power is equal to 1 divided by f. Okay. Now, how to define this? Actually, power is tangent of deviation suffered by a parallel ray incident at a distance of 1 unit from principal axis. Is it clear? Yes. Okay. So what is the SI unit of power? 1 by meter, or it is mainly called as diopter. So if you measure the focal length in terms of meter, you write it as 1 by f in terms of meter. So when you write the focal length in terms of meter, the unit comes out to be diopter. Whereas if you write the focal length in terms of centimeter, then what should you put in the numerator? You'll put 100. So 100 divided by centimeter is also diopter. So in a problem, if they give you the value of f in terms of meter, you directly use the formula 1 by f. If they give f in terms of centimeter, you use 100 by f. 100 by f, where f is in centimeter. Is this point clear? Right. So this is all about lens diagrams, lens formula, linear magnification of lens, and power of lens. So one last concept left out with respect to lens is lens maker's formula, which will take at least 20 minutes for me to explain. Okay, I don't have time. So we have another class, right? We'll do a problem that is based on refraction and spherical surface. Humanoid, defects of humanoid, right? You don't have. let's say there is an object placed here, which is at a distance of 10 centimeter. Okay. Here the refractive index is 1.5. Here it is 1.2. Okay. The radius of curvature of the surface is 12 centimeter. Find where the image is formed and complete the ray diagram. So find out which is mu2, which is mu1. Done. What is the answer? Plus or minus? So this is mu1, this is mu2. So mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. So what is mu2? 1.2 divided by what is the value of v? V is v only. Minus mu1 is 1.5 divided by u is minus 10 is equal to mu2 minus mu1. 1.2 minus 1.5 divided by r. That is 12, which implies 1.2 by v plus, can I write it as 15 divided by 100 is equal to, I'll get minus 0.3 divided by 12. Now 1 by 40 here, the negative sign, which implies 1.2 by v is equal to minus 1 by 40 minus 15 by 100. So when you solve this, are you getting v minus? Did everyone get 9 minus 9.6? Right. So if that is the case, I want you to complete the ray diagram and show. Ray is traveling from Rays traveling from denser to rarer medium. So how will the ray diagram look like? The first point I gave you, I asked you to draw a ray diagram, right? Will it not look something similar to that? Is almost close to the because the object distance is 10 and the image distance is minus 9.6. So the distance between them is just 0.4. So now you got an understanding, right? We'll do slightly tougher problems. Maybe after I teach you lens makers for very important lens makers. With that lens section is over, then we have prism and optical instruments. With that the chapter is over. Okay. So one more point is listen to this carefully. We have completed test only for 4 chapters, right? So next week it's fine. After that, again, I'll start the test part. Okay. So ensure that you are preparing well. Start preparing and be ready for the announcement. I'll give you the dates. As far as possible, come and write it here. Don't write it at first. Okay. Breathe up. So be ready for it. And apart from that, I wanted to mention one more point also that I'm not sure what you guys are doing on Saturdays and Sundays. I can clearly see that preparation levels are a little down only. Correct? You're not working hard. What is supposed to go for the board exam part? Okay. So weekends also, how I'll utilize this one week or something. I'll be giving daily practice tests, which you can take it in the app itself, which is mandatory. Just because I've given it in the app, don't copy and get marks. It is not for my sake that you're doing. You guys are in 12th standard, have some responsibility. Even if you fail, I don't mind, but do it sincerely. Is that point clear? So you'll have only half an hour test. It will happen for each subject. Let's say on Saturday and Sunday, I need you to spend at least 1.5 hours each. Is that clear? So each subject will be only for 30 minutes. We'll have 15 questions or something. Your job is to solve, mark the answer there. On spot, you will get the marks. Okay, DBTs are ready. Start working on them also because you have MCQs as well, right? In your test, are they testing MCQs as well? Physics? Okay, it's better. We don't know what kind of paper is going to come. We don't know the blueprint yet. So those questions are going to be MCQ based. So better solve them. So I'll prepare the schedule and give it to you. Last year, I'm not sure how many of you. So last year, who were with us, you will know what I did in the last minute. If you remember, I gave something like DPPs. Each chapter you had 2 assignments as tests. Remember that? So it will be something similar to that, but I'm doing slightly in advance so that your weekends are also not wasted and you're in touch with the subject. The clear assignment, I know what you people will do. Better write a test sitting at home. So, yeah.
Sir, what is the learning?
What?
Online test.
Evening there. I'll give a schedule. Okay, I'll give a window. Not like the time half an hour, exact half an hour. I'll give 5 to 8 window. But once you start the test, timer started. Don't try to cheat. If you come out of the app, it's gone. It'll show as you have completed and then don't ask me to reassign it. I cannot do that. Please. So another be sincere. You're working for yourself. Clear? Any half an hour. Yeah, I'll give a window. Any half an hour, I'll give a window. So whenever you start, a timer started. Half an hour, try to complete it in 25 minutes. MCQ. So that's it. I hope those who are online also understood.
Yes, sir.
Yes, sir.
Okay. We'll wind up. Okay.